All right, let's go ahead and take a look at some balancing problems. So the first one here, our goal is to make sure that both sides of the equation are the same. So first, let's divide it into the left and right. So we're doing this at the reaction arrow. We have our reactants on this side and our products on this side. So to look at our elements, we're going to have N, H, and O. So N, H, and O. If we're counting them up, N, we have two N's, one here and one here. We have four H's, and we have three O's. So that's on the left-hand side. On the right, we're going to have the same elements, N, H, and O. So we're going to look at the places where they are. So N, we have two here. O, we have one here. And H, we have two here. Okay, so since we have O in two separate spots, we're going to put them separate here. So this one is for this auction, this one's for this auction. We'll see later because whatever number we put here is going to affect this oxygen here, but not this one over here. So we want to keep it separate. Here we can combine the ends because whatever number we put in front, it'll take both of those. Okay, so our goal is to make sure both sides are the same. So if we look at it, we have two N's and two N's, so both sides are good for N. H's, we're short. We have four on this side, we have two on this side. So the first thing that we're going to try to do is make H the same on both sides. So if we're looking at this one here, we want to get our total of 4 here and 2 here. So if we put a 2 in front, this is going to multiply both of these out. So this times 2 would give us 4. So that's good, but it's also going to change this oxygen, 2 times 1. So we're going to multiply by the second one here because this will represent this oxygen. So we're going to get a total of 2 oxygen here. So if we look at our total, so this is going to be 4 H's, which is what we want, 2 N's, which is what we want. And if we look at oxygen, we have 3 here. We have 2 times 1, 2, plus the 1 here. So we can put a 1 in front so we don't have to change that number. So if we do this times 1, we'll get 1. So we can add this together and get a total of 3. So this is the balanced equation. We can leave these blank or fill in ones. So 1 N4 NH3, NH4 NO3, 1 N2O, and 2 H2O. So that's our coefficients, 1, 1, 2. All right, let's look at the next one. So the next one here, we want to count up our elements to start off with. We have K, we have H, we have O. And on this side, we have H, O, and K as well. So let's keep them in the same order. K, H, and O. All right, let's count them up. Here we have 1K, 2 H's, and 1 O. On this side here, we have 2 H's plus the 1 here. So we'll have 2 and 1. 2 for this one, 1 for the one at the end, 1K, and 1 O. All right, so if we look at our problem here, we have 1 O, 1K, so that's good. But here we have a different number of our H's. So we have 3 on this side, and we only have 2 on this side. So to make this work, we can't multiply this by a whole number to give us the 3. So what we do is we're going to do the smallest next one. So if we put a 2 here, this is going to give us 4. And now we can change this side to give us 4 as well. But that's also going to affect the O. So here we'd have this times 2. So we get a total of 2 oxygen. Okay, so on this side here, we want 2 oxygen. So we're going to have to multiply this by 2. And so that's going to multiply everything out. So this gets multiplied by 2, so we get 2 here. This gets multiplied by 2, so we get 2. These two add together. So this would 2 plus 2 would give us 4. So that's okay because we have 4 on both sides. And then lastly, we have 2 times K. This would give us a 2K. So far, we have 2 H's on both, 2 O's on both sides. We have 4 H's on both sides, and we need 2 K's. So the last bit is to put a 2 in front. This is going to multiply out, so this will give us 2. And that's how we can balance these ones here. So those are the first 2 problems.